Hello students, let us see exception handling in C++. First of all, we need to understand what is exception. In programming, there are two types of errors. One is the compile time errors, which are caught by the compiler. For example, syntax error like semicolon missing. The second category is runtime error. These are anomalies or abnormal conditions that a program encounters during its executions. For example, division by zero or violating array index. These runtime errors are called as exceptions. If exceptions are not handled properly, it results in abnormal termination of the program. Let us see example. Now, in this program, I have written one simple function called as divide. If you see the function here, I'm just taking two parameters, dividend and divisor, and the result of expression dividend divided by divisor will be stored in result, and I'm just returning this result. Now, in the main program, I am taking two inputs from the user in the variables a and b, and these are passed to the function divide. Once function call is finished, C will hold the result, and that result is displayed with the cout statement. I purposefully put one statement there, that is end of the program. Now let us compile this program and see what is the output. So clang++ is the compiler. Name of my program is exception1.cpp, and now I want to execute it. It is initially waiting for the inputs. Let me give 15 divided by 5. As expected, result is 3, and end of the program is executed properly. Now let me run this program one more time with another input, say for example 15 and 0. So basically I want to divide it by 0. Remember here the problem is it says floating point exception and the exception number is 8. You need to observe that end of the program, this output, the last line in my program is not executed. That is because the exception is not handled and my program is terminated abnormally. Now, how to handle these types of error? Let us go back to the presentation. Let us see what are the advantages of handling the exceptions. The first thing is separation of error handling code from the normal code. Without exception handling, typically in C programming language, we make use of if, else, but that is difficult to understand the code for the maintenance, and actual good code and error handling code is mixed together. Second advantage is functions or methods can handle any exceptions they choose. That means error handling can be done at the function level, or that could be handled by callee of the function. Third advantage is we can group different types of errors with exceptions, typically when we have exception classes. Now in C++, exception handling is the process of handling errors and exceptions in such a way that they do not terminate program execution abnormally, and for which C++ provides three keywords. First one is try, which is used to create the try block. This represents a block of code that can possibly throw an exception. Second keyword is catch, and this represents a block of code that is executed when particular exception is thrown. Remember that for a single try we can have a multiple catch blocks, so based on type of exception we can handle different exceptions. Third keyword is throw, that is used to generate and throw an exception, and that is also used to list the exceptions that a function throws but doesn't handle itself. Now let us look at the syntax for exception handling. So the syntax is very simple. We have the try block. For example, you can see it here. We have a try block which will contain number of statements, and this statement contain the throw statement directly making use of the keyword throw, or it may have a call to another function which will throw the exception. So that is indirect exception occurred here. After try, there are catch blocks where we want to catch the exceptions. Exceptions are handled by its type. So for example, first catch block is with type 1 exception, second is type 2, and these types are nothing but the data types, primitive data types or user defined data types in C++. So this is the syntax for handling the exceptions. Now let us see the flow of execution with try and catch blocks. This is a very simple program in which I use exception handling. Program execution starts with main. I declared one variable x equal to -1. Now this is very first statement which displays before try. So there is absolutely no doubt before try will be outputted as it is. Now we are going into the try block, and very first statement in this is again one more cout. So definitely this will be executed saying inside try. Now next is the if condition which will check the value of x. We initialize x with -1, so definitely this condition is true, which will throw x That means we are throwing the value of x, which is -1. So this type of exception is integer because the data type of x is integer. The important thing is once exception is thrown, the code below that will not be executed. So this statement is not executed. So you cannot see this after throw in the output. Now this throw x transfers the flow to the catch block. So because we have thrown the value of x, the appropriate catch box for that is integer. So this will be caught. No execution continues from this one. In the catch block, we just displayed exception caught. So same thing appeared in the output, exception caught. And because we have handled the exception, program is not abnormally terminated. So it will execute the next statement, that is after catch. So that is how the flow of execution with try and catch block happens. Now there is a special catch block called as catch and in parenthesis dot dot dot. As I already mentioned, the data type of throw, that is the exception argument, and data type in the catch should match. For example, in this program, my program starts with try block in which I just thrown 10, where data type of 10 is considered as integer, but there is no matching. So first catch data type is character star. So 10 cannot be matched with character star. So we should have actually matching catch with integer data type, which is absent here. So there is a special block called as a catch all. So we can write like this, catch dot dot dot. So if no matching catch block is there, this catch all block will be executed. So this time it will execute like default exception. That happens in the output also. So in this program, integer is thrown, but there is no catch block. So catch all, that is catch dot 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 block will be executed. Remember that you cannot add any other catch block after catch all block. That means catch dot 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 must be the last catch block for your try exception handling. Not only this, you need to take precaution of implicit type conversions that usually happens in normal expressions in C and C++. That won't happen in case of exception handling. That means, for example, we are throwing a here in single quotes. That means it represents character data type, and typically that is converted to integer. That won't happen here. That means a cannot be converted to integer, and because we have catch all block here, the result will be default exception. So in this program, if we have not written catch dot dot dot, then definitely it will be resulted into abnormal termination. For example, in this, if you see, we are trying to throw a and there is no matching catch block. So you can see the output. This is the abnormal termination condition saying that program is terminating with uncaught exception of type char. So remember, this a represents character type, not integer. Exception handling in C++ plays differently in case of the user-defined types, typically when we use base and derived classes as an exceptions. For example, in this program, I have a base class. This is the empty class. Derived class, which is public derivation of this base class. Now I declared object D. Maybe some other stuff you could add. Now in try block, we are throwing D, and now data type of D is derived. So if I write catch base B, that means the type of catch block here is base. Second is type of this is derived, and because we are throwing derived type, we may think it will caught the derived exception. The problem with this is if both base and derived classes are caught as exceptions, then catch block of derived class must appear before the base class. Meaning of this is very simple. If you throw the object of derived class, that will be caught by base class. So you can see that in output it will say caught base exception. One of the beauty of this exception handling is we can nest the try and catch blocks, and we can handle the exceptions partially. For example, you can see here try blocks are nested. Inside try block we have thrown 20, which will be caught by this catch, and output is handle partially. So that happens in handle partially. Now one important thing is I just use throw here, and meaning of this is when you use throw, try to get the difference between throw 20 here and just throw. Throw 20, it is in try block, and throw is in catch block. So if you use throw in catch block, whichever the exception caught will be rethrown. So throw can be used to rethrow the exceptions. Now remember, this throw will go to the outer try block, and for which catch int n. So matching, why I'm saying matching, because integer is caught here, which is rethrown, that can be caught in this statement. So this will result in handle remaining, and that happens in the output also. So function can rethrow the caught exception using throw without any argument. One more important thing is the objects created in the try block, they have the local scope. So whenever exception happens, they must be destroyed. So for example, a sample test class is created here. While creating object, the constructor is invoked. Just one cout statement is there. And whenever you destroying object, destructor of test, that is invoked. Now in the main program, you can see we created one object t1 of type test. We simply say throw 10. That means we are throwing the integer exception. But because this moves the control out of try block, the object t1 whose scope is local must be destroyed. So whenever exception occurs, all objects created inside the enclosing try block are destructed before the control is transferred to catch block. So when you create the object test t1, constructor of that class is invoked. So that is the first output statement. Whenever you throw the exception, t1 must be destroyed. So destructor of the same class is called, and then cout caught whatever the value. So the exception handling code will be executed. So the order is constructor, then destructor, and then exception handling code. Now, how to specify the exception for a function? The dynamic exception specification follows the declaration of a function, appending a throw specifier to it. We already aware that this is the return type of the function. So if you read it, double my function character parameter. So this declares a function called as my function, which will take one argument of type character, and this returns value of double. Whenever I say this function throws two types of exceptions, integer and character star, so this is called as exception list. And to specify that function throws integer and character star, you should append the throw specifier and list all the exception in the parenthesis. To conclude, the C++ exception handling mechanism